let's jump back into another question of Leetcode 121, best time to buy and sell stock. You are given an array prices where each element is the price of a given stock on the ith day. So here we can see that the index ith day corresponds to the ith day's stock price. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Let's see. So we have our input prices given as 7, 1, 5, 3, 6, 4, and we have to find a profit value that's maximum within these days. So at this, on the 0th day it's 7, on the first day it's 1, on the second day it's 5, on the third day it's 3, on the fourth day it's 6, on the fifth day it's 4. So how do we do this? I can think of a couple of different solutions. One of them would be to have a nested for loop, and like for each of these elements we can subtract the values on here and carry a running maxsum that would end up giving us the max profit. Okay, let's code up the brute force solution at least before we jump into the next solution. So we want a running profit value. So that would be var max profit equals to, let's initialize to 0. And then we want to loop over prices. So let's do for I in we want to go to the length of prices, so 0 prices dot count. Okay, and then we want to start from the next index to the end of the array. So for j in range I plus 1, oh, that's Python. So for j in 0, no, I plus 1 in the range prices dot count, profit, let profit equals to prices of j minus prices of I, because we expect the price of the stock to be larger than the price we are comparing to right now. This would give us a positive value, hopefully. If it doesn't give us a false positive value, then we break out of the loop. So let's see what happens if we get a positive value. So if profit is greater than max profit, which means it doesn't matter if it's lesser than 0 or greater than 0, but it has to be greater than max profit bar. But our max profit is equal to 0, so profit will always be greater than 0 if this block of code runs. So if it's greater than max profit, that means we can assign max profit as profit. Okay, and now once we're out of here, we'd have some value in max profit. If we don't, we always have 0. So that fallback enables us to return max profit here. Let's see, what's the problem of prices? Okay, I'm assuming there's a runtime error because this is too inefficient, and I'm assuming there's a lot of test cases that deal with large sets of arrays. Let's look into a better efficient method to solve this. Okay, so this is our input array, and I took the liberty to plot it out on an XY axis. The X represents the day, the Y represents prices. As you can see, uh, we need to find peaks and valleys in the given graph. We need to find the largest peak following the smallest valley. We can maintain two variables called maximum profit and a minimum stock that would carry the lowest amount of stock value we've seen up until now. And we could go through each one of these at every iteration. We can check if there is a positive greater profit than the existing profit we already have in as variables, and we check if this is the minimum value of a stock we've already seen. Let's look into a simulation of that solution. So initially we'd have max profit as negative, no, positive, that'll be negative infinity, and minimum stock value as 0. We've not parsed through, we've not seen any stock values, and we just set it to 0 initially. Going through all of these elements, when in the loop 1 element is equal to 7, index is equal to 0, we'd see we need to get the max profit. So we can find that by asserting a max value of max profit and E, that's the element we are at right now, minus minimum stock value. This here it will give us max of negative infinity and 7 minus 0. That's 7 for us. Then we go again with loop 1. Element equals to 1, I equals to 1. Max here would be 7, comma, element 1 minus minimum stock. So minimum stock here, up here is 7. 7, that would mean it's still 7 max profit, and minimum stock value becomes 1. And if we keep continuing, we'd go through 1, we'd have min stock here as 1, and when we reach 5 here, no, 6 here, minimum stock here is 1, value here is 6. We would see that the difference or the profit here would be 5. And if you run the simulation on your own, you can always see that this would be greater than any of the other values. That being said, let's jump back into the editor and see how we can code it up. Coding solution. We needed two values, min stock and max profit. Now we can declare min stock as the most minimum value in the prices, but we're starting from the first element, so we can initialize the min stock as prices of 0. And the max profit we can have is negative infinity. And now there's a couple of ways to do this, but I like to do it since we're dealing with integers. It's int.min. This would give us the lowest possible value an integer could have. Now, we want to run through all of the prices and figure out min stock and max profit here. So for price and prices, we first get the max profit. That will be max profit equals to max of max profit and price minus minimum stock. That's 7 for now. And min stock, would be minimum of min stock comma price. And once we have that, we can just return max profit here. We could also check if number of prices are less than 2 and return 0. And yeah, I think that should do it. Looks like it works. Awesome. Thank you for watching. If you like this kind of videos, do subscribe and hit the like button. See you in the next video.